Thank you. Appreciate the opportunity. So I'm going to introduce you to TidalScale and a technology that we have developed, which truly is a breakthrough. I know that's a term you hear a lot, but truly is a breakthrough. And we call it software-defined servers. If you go on to the next slide. So let's first talk about the challenge. We all know it's all about data. We got to get the most out of the data. Military, of course, has known this for years. Businesses have really started to catch on to this in the past decade. Now, data, we process it in computers, and computers have been driven by Moore's Law. Moore's Law has driven the technology industry for the past 4 decades. But the challenge is that Moore's Law has predicted over the past 12 years that computers would be over 200 times higher performant than they actually are. So Moore's Law is dead. But during the same time, data has been growing at this exponential rate. And so there is a huge gap. There's a huge opportunity. That's where TidalScale fits in. If you do one more click. So now the key is doing processing of data in memory. Why is that important? Because DRAM is 1,000 to 10,000 times faster than the fastest flash storage. You know, we don't really know what nanoseconds and microseconds and milliseconds all mean, but let me put it in perspective. If DRAM access is 1 hour, then we're talking about storage being measured in months and years. And that's a huge, huge difference. We got to keep the data in memory. So what are we doing about it? Or what is the benefit? The benefit, if you go to the next slide, is that we get performance by putting and creating systems that are big enough to put everything in memory. We're not yet working actively with the military, but this is a business application that I think has a lot of similarities to a battlefield. And that is the tracking of people at a Major League Baseball game. Yes, cell phones, all these other Bluetooth devices are all being tracked as you walk into a stadium. They can measure within a foot where you are. All of that's being captured. It's anonymous, don't know who the person is, but the movement of this is all captured and then is processed to try to make big analytic decisions on how to have improved performance, how long the bathroom lines are, how can we make people spend more money, happier events, etc. Working with our partner in this particular one, it was taking 30 days before TidalScale to do the processing at AWS. After TidalScale, they could process it in 5 days. And also the processing can now even be moved to the location. So out to the field, do it at the stadium where actually you can get to true real-time processing of an individual game. So huge benefits. Go on to the next slides, if you will. So what we have created is the software-defined server. Another click. And then basically what we do with this is that we combine standard servers together, one more click, into a system that is a virtual server, the software-defined server. So standard x86 servers just connected with Ethernet, no change to the operating system or the application, and it just runs. The difference is we now have the ability to create a system that is sized to the data. The benefits of it are huge. I'll touch on that more in a moment. One more click will show you a small list of some of our customers and partners from around the world. Okay, next slide. So the benefit of this is measured in several things. First, performance. We get all the data in memory. Also, a part of our secret sauce is that we have the industry's first use of real-time machine learning within the computer itself. So we do that with built into our software. We are able to drive down cost by using standard servers and the ability from an agility standpoint to create and resize in minutes, make it bigger as required, scale down if necessary, huge agility. And the next thing that we are in the process of adding right now, when we're click, is increased reliability and uptime. So we have a technology that will allow us to avoid 90% of failures, as well as recover 100 times faster than it takes today to recover and fix a standard server. So putting to some numbers, one more click into what our customers are seeing. What they are seeing is benefits like 10x better performance, 50% lower cost. One more click, please. Being able to do a deployment that is 25 times faster than they were able to do before. They don't have to do the analysis. They just deploy, measure, and modify as requirement, and reliability and uptime that is 100x higher than what is being seen today. So huge overall benefits in what we are bringing to the customer. Now, let me give you one final kind of view of where we're going in the future with this technology. One more click. And that is, our vision is that systems should be self-optimizing, self-healing, and self-sizing. Now, these capabilities, self-optimizing, self-healing, self-sizing, they've been around for decades with networking and storage. However, standard computing doesn't have these capabilities. What we've done with our real-time machine learning is we are bringing self-optimizing already. We're bringing self-healing with this new capability of TidalGuard, where we can hot swap a system and basically get this 100x improvement in uptime. And self-sizing is a capability that we will be adding in the future, and that allows a system to automatically adjust to the actual data requirements, which is something that has never been possible before. So go on to the next slide. So let me leave you with a quote here from one of our friends and advisors, and it's Gordon Bell. He's an industry legend, American computer legend. He invented was the father of the mini computer. The Gordon Bell Prize for High Performance Computing is essentially the Nobel Prize for High Performance Computing. And essentially what his view is that these innovations and this innovation layer that we have developed at TidalScale is the way that all servers will be built in the future. They can be deployed in big data centers, they can be deployed in a Humvee, they can be deployed in an aircraft, because we're just using standard building blocks as our key to how we put this together. Now, as far as our ask, we're working in the commercial environment today. Ike Nassy, who is our CTO and founder, has done a lot of work in the past with DARPA and with governments. He ran all the software at Apple. He was the chief scientist at SAP, many other great accomplishments. And so we are interested in government funding to accelerate this roadmap. We have innovations that the patents have been issued on it, but we haven't been yet able to fund it. And we believe this is great dual use technology from that standpoint. And the last ask is that our technology is in production. Our third generation is already in production. We're soon going to be releasing our fourth generation. And this is a technology that we know has great applicability for the military, for government applications. And we would love introductions and opportunity to help support that. Also here with me to help answer questions is Dave Ferretti. He's, I know, texting in the chat session. Dave heads up our worldwide sales operation, and so Ike and myself and Dave are all here to answer your questions.
Perfect. Thank you so much, Kay. We're going to open up the floor now for questions. Feel free to just go ahead. Derek, on you.
Yeah, hi. Thank you for that presentation. So I'm interested in the application with respect to Major League Baseball. I'm close with the owners of one of the teams. Could you tell me where you're at from a technical readiness level for a deployment to a baseball stadium? Because I believe I understand the value proposition there.
Yeah, so our technology is a core foundation technology. And so in this case, we're working with a partner who basically, they have the application that's actually doing the tracking, and the technology does the tracking of Bluetooth and wireless devices. But the problem is the data is coming in so fast. How do you absorb the data? And then how do you do the analytics on the data in real time? And that's where we come in. We basically have created that technology that allows it to scale to whatever size, whatever granularity of the data that is required. So Circle is the name of that company, and we're a close partner of theirs, and they use us for multiple of their other use cases, including baseball.
Thank you.
Mm-hmm.
Just a quick question. When you talk about application in government setting, is it just the same technology, the same way a data center would be using it, the same thing for a government data center, or is there something unique here that you need to do to tailor it to gov?
So the core technology is going to be similar. There is no doubt, as we get into specific government applications, I would expect that there could be optimizations that could be be made for those. But also, I think the ability, particularly from a government standpoint, the dealing with computers and creating systems of an indeterminate amount of size is a huge challenge right now. It's a big issue for the industry, and being able to address that fundamental is a big opportunity. The second thing is the self-healing can't be underestimated as well. And the reason is that these big systems, which are needed, also become inherently unreliable. And we basically, with what we're doing, we bring reliability back to these very, very big systems.